So hello everyone again. This is lecture 8 part 2 of wave optics. Let us move on with the further discussions of polarization. In the last lecture we completed with the diffraction concept. Today we will start with polarization again. I will try to understand the concept which was already left in the last lecture only about the electric and the magnetic waves thing. So I am Samir Lavankar. Let's begin our discussion. So a little bit course outline for you. Right now we are in the polarization concept, that is the last lecture of this. Before this we started with the diffraction concept. Before that we were in the Young's experiment in which we understood the interference fringes concept. Then before this the application part was being explained in the coherent and incoherent addition of waves, in which we found out the intensity is maximum for coherence and it is minimum for incoherence. Before that we went on to the Huygens principle, in which we understood the concept of refraction and the reflection laws. Before that we understood the concept of Huygens principle, that is wavefront concept, definition of wavefront and so on, and before that we started with the wave, how it is different from Descartes theory, etc. So let us move on with the polarization concept again. So let me try to explain you everything which I made you teach in the last lecture in the last 5 to 7 minutes. So I was trying to explain you this concept. So let us suppose I make a let us suppose this is a propagation direction, that is x. Let me write here direction of propagation. Let us say this is direction y, that is the direction in which there is a vibration in the electric signals, and let us say z is the direction in which there is a vibration in the magnetic signals. Okay, so now let me make a diagram. So let us suppose okay, now please listen here carefully. So let us suppose this is the electric signal being talked about here. Let us say this is the electrical waves, and let us suppose this is the magnetic waves. So for any type of signal to pass from point A to point B, there should be vibrations occurring. So that vibrations we are assuming with this line signal. So these what is happening is, let us suppose there need to be a processing of light from point A to point B. Then these signals in the form of sinusoid will go from point A to point B. How will they reach there? We are assuming it to be a sinusoidal form in which they are rotating like this, and there is a vibration. So the vibration for the electrical signals will be in this direction only. Let us suppose that this is the propagation. Then the vibration will be in this way only, either up or below. Similarly for magnetics it will be only this direction, so it will be only sway direction. Similarly there can be multiple way of radiance of lights emerging from point source and then moving on to you. So then the direction can't be only for magnetic waves to be like this only, it can be like in this way, so that the magnetic will be always perpendicular to it, and similarly there can be different directions in which the magnetic waves will be forming. So for now we are assuming that the light is being processed only by the electrical signal. So for now let us remove this magnetic part. So let us suppose there is no magnetic part and only the propagation is happening due to the electrical signals. So this is the form which we will get directly, that is electrical waves. So now what I try to understand is, let us suppose we are viewing this from this place. Let us suppose our eye is being kept here and we are viewing it from here. So let us suppose we are viewing it from here, then this can be viewed as this. So either the direction of propagation can be above or below. Similarly what I try to make you understand is, let us suppose this is only a single monochromatic source of light coming from this direction, but let us suppose it is a white source of light, then the electrical waves can move on with different wavelengths. Different wavelengths will have different directions in which they are interacted coming from the source. Therefore there is not only one electrical wave, there can be several electrical waves inclined at different angles from, let us suppose if we take this as the datum. Therefore the complete orientation can be, if I make 2-3 lines. So let us suppose this is one direction, let us suppose this is the second direction, let us suppose this is the third direction, let us suppose this is also one of the direction. These are all the electrical signals only. Now what I try to do is, as all these are waves only, they can be divided into two components, one in the x direction, one in the y direction. So I just convert it. So nothing can be, it can be, so this can be directed into two places. One can be this here and here. So x component will go here, y component will go here. Therefore the final denotion of this light can be in this form. So this denotion is nothing but called as an unpolarized light. So this was the only concept which I was explaining you in the last lecture. Now how to convert it into polarized light, what is polarized light, what is a Polaroid, why is there a need to convert it, these all concepts we will understand in this concept. Okay. So now let us move on with our discussion only directly. So please look over here carefully. So consider holding a long string that is held horizontally, the other end of which is assumed to be fixed. So we are just assuming that one end is, let us suppose this is the rope which we are conducting, and let us suppose this is fixed here. Now when we try to move one of the string end up like this, if we are trying to sway it, then there will be waves forming. This is one of the example of how these waves will be formed. So consider holding a long string that is held horizontally, the other end of which is assumed to be fixed. So we are assuming one end to be fixed. If we move the end of the string up and down in a periodic manner, please make sure we are moving the string up and down in a periodic manner. There is no unperiodic movement, non-periodic movement being kept about here. Then we will generate a wave propagating in the positive x direction. So quite evident, we can find out at any time t, if we stop and take an image, we can find out that the wave is propagating in the x direction. So this is the direction in which the propagation is being done. Now as you can see that the value of t is 0 and it is at delta t, it has been moved. So it's a movement which is happening in this direction like this. So it is being told that the wave is generating or propagating in the x direction. Such a wave could be described with the following equation. As I explained you this concept also, in this concept also I explained to you that we are assuming that everything is being kept, or the propagation is happening in a sinusoidal form. Therefore we are assuming it that the equation of the wave is nothing but a sin kx minus omega t. So just explaining you everything here. So what is A? A is the amplitude. So this can be understood as the amplitude. What is the maximum amplitude? Sin is as a sinusoidal form. Then omega t is the time, the period for which the value of the y is 0 again, and kx is just, it is shifting from its original position. So this is the equation. So I explained you the equation why it is of this form. Please make sure here the equation is a function of two things, one is x and one is t. So for any x and t given, we can find out the value of the waves, what is the position. So position of the wave can be only the locus of these all points. Okay, so now let us move on. Such a wave can be described as the following equation. So a sinusoidal wave can be understood. Now where a and omega represent the amplitude, so I explained to you what is a is the amplitude here, omega is nothing but 2 pi nu, where nu is the frequency, and angular, so omega is nothing but the angular frequency of the wave respectively. Further we know that lambda is equal to 2 pi by k represent the wavelength associated with the wave. So wavelength also we know, wavelength is nothing but the difference between the two crest or two trough. So if I try to explain you using this concept, let us suppose I am taking a distance here to here, then this is known as wavelength. Similarly if I take the distance from this to this is also known as wavelength. See, the wavelength concept is also explained to you in this photo here. Okay, so wavelength is nothing but 2 pi by k. So k is just a denotion of which is representing the wavelength. So 2 pi by k represent the wavelength associated with the wave. Since the displacement which is along the y direction is at right angles to direction of propagation of wave, we have what is known as a transverse wave. So this is the same concept which I was trying to explain to you, as the direction of propagation, as this is the direction of propagation and this is the direction in which there is the movement, there is a displacement in the wave. Therefore this type of wave is called as transverse wave. So since the displacement which is along the y direction is at right angles to the direction of propagation of wave, quite evident, as you can see that the direction of propagation and the direction of movement or direction of displacement are perpendicular to each other, that it is 90 degree to each other. Therefore this is known as, this type of wave is known as transverse wave. Since the displacement which is along the y direction is at right angles to the direction of propagation of wave, we have what is known as transverse wave. Also since the displacement is in the y direction, it is often referred to as Y polarized wave. So this is nothing but Y polarized wave. That is, so as I also explained to you, if and only there is only one sequence, there is no x direction or there is no wave for which the electrical wave signal or the displacement is in x direction, it is only in one single direction, then that type of wave is called as polarized wave or polarized light in this sequence. Okay, so this thing is also being done. So now this thing is done, that also since the displacement is in y direction, it is also referred to as Y polarized wave. So if we are only taking the consideration of Y polarization, then it is known as Y polarized wave. Since each point on the string moves on a straight line, the wave is also referred to as linearly polarized wave. So what does it mean by linearly polarized wave? Because every point, so this was the original, let us suppose that if the string is being intracted, there is no movement of our hand in periodic manner, then the complete string can be said in this direction, that this black line can be understood as the wave. So what is the movement being done? The movement of each of the points which are being held apart in these positions after some time t are at these positions. So because every movement is happening on a linear propagation only, everything goes in linear propagation only, if the points can be viewed from above or below, it can be seen in a straight line. Therefore this is also known as linear propagation wave, sorry, linearly polarized wave. Further, the string always remains confined to the xy plane. Quite evident, the string won't move in either from x or y direction, it can't go to z direction because there is no force which is acting in the z direction. Therefore the complete movement will be in x and y direction only, in the x and y axis only, x and y plane only. Further, the string always remains confined to the xy plane, and therefore it is also referred to as plane polarized wave. So because it is confined to xy plane, again it is known as plane polarized wave. So we got 4 different definitions of a transverse wave, or for any wave which is moving in this direction with the movement being intracted in perpendicular direction or the direction of propagation. So because I will try to revise everything again. So because the direction of propagation was different or was at 90 degrees to the displacement, therefore it was called as transverse wave. Then the next concept was regarding, because the displacement is only in the y direction, it is also called as Y polarized wave. Then next was because every point before propagation was on a straight line, so because due to that propagation we can understand that this is also called as linearly polarized wave, because every point is in linear, is linear, that is why. Next thing is that it is always on the x and y plane only, therefore it is also known as plane polarized wave. So these were all different names, you just need to remember these names. So transverse wave, then it is Y polarized wave, then it is linearly polarized wave, and then also known as plane polarized wave. So these were different concepts. Okay. Then in a similar manner we can consider the vibration of the string in the xz plane, generating a z polarized wave whose displacement will be given by. So only what they are trying to say is, let us suppose we are taking a scenario in which the movement or let us say the electrical signal is intracted in this direction. So if it is intracted in this direction, if we see from this naked eye here, then the direction will be, or the polarized wave will be like this. So because this is in z direction, it is also known as z polarized wave. And therefore the equation for this will be, then is nothing but z, which is a function of x and t, a sin kx minus omega t. The equation will be same, only the displacements area or the position of the points which are acting will be in z direction, and in this was, before that it was in y direction. So it was moving like this for y. Let us suppose this is the direction of x, this is the direction of y, and this is the direction of z. And if the propagation is like this, then before equation the displacement was happening in this scenario, and in the z direction one or xz plane one, the direction of propagation is in this scenario. Okay, so this thing is also being understood. Let us move on. So it should be mentioned that the linearly polarized waves are all transverse waves, quite evident, because everything is happening in a linear sense. If it is happening in a linear sense, it is for sure that it will be perpendicular to the direction of propagation of light. Either it can be, if I try to explain you using different equations, or let us suppose, so anything, this is also a linearly polarized wave, then this is also a linearly polarized wave, this is also a linearly polarized wave, this is also a linearly polarized wave. Every wave is linear polarized wave as long as let us suppose, I am assuming this to be the direction of propagation of light. So this can be a linearly polarized wave, similarly this can be linearly polarized wave, this can be linearly polarized wave, and even this can be linearly polarized wave. As long as the displacement is perpendicular to direction of propagation, then it can be called as a transverse wave. Therefore every linearly polarized wave are all transverse waves. That is, the displacement of each joint of the string is always at right angles to the direction of propagation of the wave. So this is the same thing which I already explained to you right now. Finally, if the plane of vibration of the string is changed randomly in very short intervals of time, then we have what is known as unpolarized wave. So now what is trying to say is, if we are changing the plane of vibration. So let us suppose if I am trying to explain you, if this is the thing this is the same string which was being propagated in this direction. If in very small time sequences I change this to this, or I change it to like this, or I change it to like this, that is, I just change the periodic manner in which I am changing the propagation. So if these things happen, then the actual propagation or the wave or the sinusoidal wave which will be formed will be haphazard, and that is something called as unpolarized wave. So this is nothing but a combination. You will see a combination of different sources coming in all the directions. If we try to, just for example sequences, so this is also an example of unpolarized wave only. So this is also unpolarized light, and this is also unpolarized light. This is nothing but, if we try to change we try to divide it into x and y coordinates, then this thing will come. Otherwise this is also an example of unpolarized light only. So finally, if the plane of vibration of string is changed randomly, as I said, it is changed randomly in very short intervals of time, then we have what is known as unpolarized wave. So this is the example of unpolarized wave again. Thus, for an unpolarized wave, the displacement will be randomly changing with time. Quite evident, the displacement will change, either it will be in x direction or z direction, or either in between x and z, sorry, not x, y direction, z direction, or anything between y and z direction. Thus, for an unpolarized wave, the displacement will be randomly changing with time, though it will always be perpendicular to the direction of propagation. Quite evident, because if it is happening in yz plane anywhere, it is always perpendicular to the x direction. Light waves are transverse in nature, quite evident, that is, the electrical field associated with the propagating light wave is always at right angles to direction of propagation of waves. So this is the simple concept which I already explained you using this diagram here, that always the electrical wave is always perpendicular to the direction of propagation. So let me stop it here only. So what we just understood the basic agenda, what is the difference between polarized light, what is difference between unpolarized light, what is polarized wave, then we understood different names or different nomenclature of how we define a wave. So a transverse wave, then we understood what is polarized wave, either x direction polarized, y direction polarized, or z direction polarized, depending on direction of propagation. Then because the x polarized wave can also come if the direction of propagation is in either y direction or z direction. Similarly, we understood what is linearly polarized wave, then we understood what is plane polarized wave. Also we understood the equation, and we understood that all the linearly polarized waves are nothing but transverse waves. Finally, we understood what is unpolarization, and hence this was the conclusion of this lecture. So let me stop it here only. In the next lecture, we will move on to different concepts of how the polarization is being done. So for this lecture, let me stop it here. Thank you.